Section 2.1, Relations and Functions. To start, let's just go over some terminology. When we're talking about a relation, we're talking about a pairing of inputs and outputs, often in the form of x, y. So just coordinate points where we have an input and an output together, such as 3, 2, 5, 7, etc., etc. A lot of times we'll see them inside brackets like this, so that makes it a set of ordered pairs. A function is when we have a relation where each input is paired with exactly one output. So each x is paired with exactly one y. So if we look at all of these x's, they're all different. That's what makes this a function. There's a number of different ways that we can display relations. So we can do them as a set of ordered pairs, like we have here. Okay, we can do a map where we have two different ovals, inputs on the left, outputs on the right, and then we just draw arrows in between them. Okay, or we can have a graphical display on a coordinate plane. All right, so when we're asked, is the relation a function? Okay, if we have a set of ordered pairs like we do in number 1, what we want to check for is, are all of the x's different? Okay, if all those x's are different, yes, it's a function because each input is paired with exactly one output. In number 1, this is not a function for the reason that this -2 has two different outputs. So in other words, that's an input that has multiple outputs. So no, this is not a function. All right, number 2. Okay, let's say we switch this to a relation, or a set of ordered pairs, I mean. So to start off, we have 1, 4. That would correspond to the coordinate point 1, 4. If we just continue that out, we have those 4 coordinate points. And if we just apply that same method we used above, we can see that all 4 of these x's are different. So yes, this is a function. Okay, the way that we would check this differently, just by looking at the map, is if any of these arrows or these numbers on the left there had 2 arrows coming off of it. So let's say this number 1, for example, had another arrow and it pointed to the negative or the 2 as well. Okay, then we have another point, okay, that also has a 1. That would make it not a function because we have 2 1s with different outputs. Okay, number 3, this is not going to be a function. We would do the same thing here. And the reason it's not a function is if we were to write out all of these ordered pairs, we can see that there's 2 ordered pairs that have a 1 as the x. So again, we have duplicate x's, okay, with different outputs, right? If we have any points that are on the same line vertically, it's not a function. And what we just did there was an example of what's called the vertical line test. For any graph, not just graphs with dots, with points, we can draw a straight up and down line. And if we hit the graph at more than one spot, the graph is not a function. Okay, so this works even if we have a line instead of points. So looking at number 4, this parabola here, if we draw straight up and down lines, we see we can only hit this graph one time, regardless of where we draw the line. So yes, this is a function. Contrast this with number 5. If we draw a straight up and down line, we can hit this more than one time. So no, this is not a function. This is called the vertical line test. If we can hit it more than one time, whether it's 2, 3, 4 times, it's not a function. On to evaluating functions. You can see up at the top here, we have 3 different functions. We have f of x, g of x, and h of x. Each has a different equation with it. And the first thing we're going to do is we're going to find f of 10. Okay, and if we look at this, in place of the x, we have a 10, which means that 10 is just going to replace all of the x's in that equation. So it's going to replace the x, and instead of x squared, it's 10 squared minus 4, which equals 96. If we were asked to find g of 10 instead, we would do the same thing, except now we're using that equation. So 4 times 10 minus 12, we get 28. If we were asked to find h of 10, there's no place to plug in that 10. H of 10 is just always 10. So in number 7, h of 9, okay, that still just equals 10 because there's no place to put that 9. In number 8, we have a bunch of different functions that we're combining. So to start off, we have f of 5. That's getting plugged in up here. G of 2 is getting plugged in to that one. 2 gets plugged into that x. And then 0 is getting plugged in over here, but there's no place to plug in. So this is just going to equal 10. Okay, and then we have a times 2 on the outside of that. So 2 times that 10. So it looks like this when we plug it all in. So here's the f of 5. Okay, so we have 5 squared minus 4. There's a lot of arrows going on here. Okay, next we have the g of 2. Okay, which is this one. 4 times 2 minus 12. And then last we have that 2 times h of 10. Okay, simplify it all out and we get 45. So in most cases, it gives you a number inside the parentheses, like find f of 10 or g of 3, all right? But sometimes it'll give you the reverse, okay? That x is still going to be inside the parentheses, and on the other side of the equal sign, it's going to have a number, like it does here. Find x if g of x equals 68. G of x is this equation. It's telling us it equals 68. So we're going to work backwards. We have an equation. We want to solve for x. So we're just going to add 12, 4x equals 80, and we get x equals 20. All right, find x if hx equals 10. Okay, if we look up here, hx always equals 10. Doesn't matter what x is, there's no place to plug in the x. It's just always 10. So this is all real numbers. Okay, you can either write out all real numbers or make that fancy looking R. It's kind of sloppy on here because it's tough to write on my laptop. All right, but it's an R with an extra line on the left. Okay, when it asks you to find the root of an equation, like it does in number 11, the root is just where it equals 0. So we're doing 4x minus 12 equals 0. Okay, solve it out. 4x equals 12. And then we get our answer, x equals 3.